we did our project on air pollution. To get started, let's go over some basics of air pollution. The definition of air pollution is the contamination of air by harmful gases or fumes. And the definition of chemistry is the science of studying how properties interact and or combine to form new substances.
And it's important to know these two definitions because if you don't know what chemistry is or you don't know what air pollution is, you won't understand how chemistry is involved in air pollution. So it's very important to know these two terms.
Let's move on to some more basic information about air pollution. As some of you may know, pollutants can be liquids, solids, or gases. When these three things build up in the atmosphere, it often becomes too harmful for the environment and or people.
Now we need to know a lot more about pollutants. Pollutants can be classified into two categories, the first being primary pollutants and the second being secondary pollutants. Primary pollutants are the pollutants that are emitted directly from a source. So an example of this is vehicle exhaust, which emits carbon monoxide. Secondary pollutants is very important because that's where chemistry comes into play. This secondary pollutants form when two or more primary pollutants interact with each other in the atmosphere. And later on in PowerPoint, we're going to explain in depth how these secondary pollutants work. Let's first talk about primary pollutants. Primary pollutants are covalent or molecular compounds. And as we talked in class, molecular compounds are the compounds that consist of two nonmetals. And the most common in the atmosphere include carbon monoxide, nitric oxides, or sulfur oxides. Others include other primary pollutants include VOCs, which stands for volatile organic compounds, and these are highly reactive compounds that are released through the incomplete combustion of industrial sources. Now, with the combination of those primary pollutants, this creates secondary pollutants, and the secondary pollutants is the chemical conversion of primary pollutants through a series of complicated chemical reactions in the atmosphere. And in order for this to happen, there has to be presence of sunlight. And with the presence of sunlight, these secondary pollutants are also referred to as photochemical pollutants. An example of this is ozone. And these pollutants are a lot more harmful than the primary pollutants.
In this diagram, we can see our primary pollutants, which include airplanes, wildfires, agriculture, factories, vehicle exhaust, and power generation. All of these primary pollutants move up into our air and mix together to chemically create secondary pollutants. This equation shows how secondary pollutants are made. When two primary pollutants mix together with sunlight, you end up with your secondary pollutant.
An example of this is ground level ozone. This is when nitric oxides combine with VOCs, which stands for volatile organic compounds, and sunlight, and that creates ground level ozone. Pollutants in the atmosphere can also create acid rain, and acid rain is rain that can be acidic by the chemical reaction in the atmosphere between these certain pollutants. To be more specific, molecules such as sulfur oxides and nitric oxides are released in the air through the primary sources. Then, in the atmosphere, these compounds combine with hydrogen atoms along with oxygen, which this is in the form of water, to create the acid rain. And it's very important to understand that hydrogen is absolutely necessary in order to make acid rain. This diagram shows how acid rain is created. As I said before, sulfur oxides and nitric oxides go into the atmosphere and combine with water to create the acid rain.
Although there are many careers related to air pollution and its chemistry, we focused in on a junior air pollution chemist. They assist in acquiring air samples and pollutants to figure out if they are solids, liquids, or gases. They also go over and review local, state, and federal air quality laws and regulations to make sure that pollutants that are tested are not harmful. In this picture, we can see a junior air pollution chemist using one of his many tools to find out whether our air pollution is harmful. Air pollution can cause some massive problems with our environment and human health. There are so many things that can affect our crops and animals and all of our other food sources. Water can also be contaminated by acid rain. Trees and other plants vital to our ecosystem and our health can become sick and die out. When pollutants are inhaled and or ingested, the body tissue can cause health problems for human and our meat supplies. In areas with high amounts of air pollution, birth defects can be often caused. Also, people who live in high areas with air pollution, they can also acquire asthma and lung infection.
Me and Lindsay also did an interview with a person named Tony Condola, and he is very experienced in air pollution. And he says, even though air pollution still is a problem, it has cleaned up dramatically. He gave us the example of a long lead was in gasoline, and it made almost everyone sick. So people in the world have come a long way in managing their air pollution, and this has helped maybe decrease a little of the human health effects. This slide just gives us a little summary of how air pollution relates to chemistry. And already throughout this PowerPoint, we discussed so much how chemistry relates to air pollution. So we're just going to summarize it and tie it all together. So to start off, to create secondary pollutants, as we said, a chemical reaction has to occur between two or more primary pollutants along with the presence of sunlight. These primary pollutants are compounds that come directly from a source, and most of them are covalent compounds. Since most of these are covalent compounds, most of them are from the periodic table of elements, and they bond together covalently to create these secondary pollutants. And also we talked about how acid rain is combined chemically with these hydrogen. It has to have hydrogen and water in the equation to create these pollutants that cause acid rain. And this is just to summarize what me and Lindsay learned throughout this PowerPoint, and this is our final statement. Air pollution along with acid rain are topics that many people, even ourselves, think are happening for no rhyme or reason. However, if you look deeper into the topic and research, you'll be able to see that these events have a whole new complexion to it. And by this, we mean that air pollution is involved in chemistry, because me and Lindsay didn't even know that. So studying this has led us to understand how air pollution is a major problem we need to fix it.
To fix our air pollution problem, you should help pitch in and recycle, ride a bike, carpool, and just try and make the best difference you can. It's all of these little things that help make this big problem get smaller and smaller. Overall, I think me and Holden both have really enjoyed researching this project. It is so great to be able to learn something on our own outside of class time. I really hope that our other peers enjoy this video and learning about air pollution.
As Lindsay said, it's very important to understand that we really enjoyed this project, and learning something in class and then bringing it into the outside world. It's really cool to see how air pollution is involved in chemistry. And if there's one thing that you need to remember from this class or from this PowerPoint, is that everything has chemistry involved in it. And me and Lindsay didn't think that air pollution had chemistry involved in it, but once we did research, it was quite amazing to see how much